And today we will, as I told, we will take practice on the nomenclature. Some structures I have written down and brought for you to explain to you for nomenclature. The next example I have brought for you. This is the chain and yes. Hydrogens are there. Every time I won't be writing hydrogen 1, 2, 3, 4, H, H2 and H3. So numbering will be from here 1, 2, 3, 4, 5 closes. So pent, it is at 2, pent 2E. And at 2 we have got propyl, 3 carbon propyl. Propyl. This propyl is at 2, but this is not straight. It will be cyclo. PR also. Cyclo. C capital. Cyclopropyl. And the cyclopropyl is at 2. So 2 cyclopropyl pent 2E. Next example is a So this is the functional group. So this will be carbon 1. We'll go clockwise 2. This is 3. This is 4. This is 5. So it is pent. This pent is not a straight. It is cyclo. So cyclo, pent, double bond is there. This is 1. Okay, not double bond. So this is your ene. Ene is at 3, pent 3 ene. And all is at 1, so 1 all. Or 1 you remove, then E you remove and you can join it. Then we have at 2 methyl, so 2 methyl, so this C will be small. Okay, then next example. One, 2, 3, 4, 5. 1, 2, 3, 4, 5. Double bond OOH. And this is CH2. And this is C2H5. Here a double bond. CH2CH. And 1, 2, 3. CH3, CH2, CH3 and CH3. So in this case 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. This way we come, the chain will be longest, but here double bond. So maximum functional group what we can include. In that case the first rule, longest chain rule, is violated. So this will be 1, this is 2, this will be 3, this is 4 and this is 5. So pent, ene is at 4, pent 4 ene, and at 1 you have oic acid, 1 ene, 1 oic acid. Then we have, this is ethyl group and this is 1, 2, 3 propyl. So E will come first. So this is your 3 ethyl. Then this branch we have. So branch also we will number 1, or you can put a dash, 1 dash, 2 dash, 3 dash. And this is 1, 2, 3 dashes, they are at 3. So we have at 3 in bracket. This whole thing will be branch is further branch, so will be written in bracket. What it is, we have at 1 dash we have this side methyl, that side. So 1 dash, comma 1 dash, di, methyl. Okay, dimethyl, and this whole thing is what? Propyl. So here we will write propyl. Propyl, bracket close, and this side we have pent. How much in? 4 in. 4 in 1 oic acid. So this is for the branch. Now next example. One, two, three, 4, and we have here the chain. So H3, H2, H and H2. So in this case we are having 1, 2, 3, 4. This won't be, because here 6 carbon is more. So 6 is more longer. So therefore root word will not be but, the root word will be benzene. This is a benzene ring. So root word is benzene. And to this benzene what is attached? 1, 2, 3, 4. 4 means butyl. So and butyl is attached at second carbon. So it will be 2-butyl. 2-butyl benzene. 2-butyl benzene. You can't write it as 2-phenyl butane. It is not 2-phenyl butane. 2-phenyl butane. If you write, this is wrong, this is right. Now one more example. That's all. Then you can do examples from the book. Many more. Okay. Now I'll start the next topic, that is isomerism. Isomerism, you know, is a phenomena in which 2 or more than 2 compounds. In your course for class 11, it is organic compound. 2 or more than 2 organic compounds, they will have same molecular formula but different structural formula. Since the structural formula is different, so their chemical and physical properties will be different. So these are the 2 different compounds or more than 2 different compounds which will be having same molecular formula. So molecular formula same means the type of atoms, type of element present will be the same, and number of each type of element will also be the same. So the type of isomerism, you have to do 2 types, that is isomerism or classification. One is structural and the other is stereo. One more is there, but that you have not to do. Conformational stereo isomerism. Structural isomerism, these are of different type. Number 1, you have to do positional. Must be having little idea about it. Second is, first is chain actually. First is chain. Second is positional. Third is functional. Fourth is Metamerism. And the fifth is Isomerism. One more kind is given in the book ring chain, but that is not mentioned in your syllabus. Only these 5. And stereo isomerism, 2 you have to do. First is geometrical, and the second is optical. So these kinds we will be doing. So first I will be taking up structural isomerism. Structural isomerism, the first kind is chain isomerism. In chain isomerism, the 2 or more than 2 compounds have same molecular formula but different structural formula. Due to the difference, the structural formula will be different due to the chain. One isomerism will have a straight chain, and the other will have a branched chain. Take one example, 1, 2, 3, 4. One very important thing I tell you, this isomerism is shown by only those hydrocarbons which have at least 4 carbon. Less than 4 carbon, this isomerism is not possible. So at least they should have 4 carbon atoms. So if I write the structure, this is here, this is butane and called N-butane. Then this is your straight chain. This is a straight chain isomer. Then if I reduce the chain 1 carbon, I branch. So I have CH3, CH, CH3, CH3. This is your 2-methyl propane. Okay, 2-methyl propane, and this is branched chain. So these 2 isomers are chain isomers. If you see their molecular formula, we have 4 carbon, hydrogens are 3, 3, 6, 3, 9 and 1, 10. Here also 1, 2, 3, 4 carbon, hydrogen 3 to 5 and 5 and 5, 10. So molecular formula is same, but the structural formula is different due to the difference in the chain. So take one more example. If you have 1, 2, 3, 4, 5, this is normal pentane. This is N-pentane, straight chain. Okay, this is a straight chain isomer. If you reduce carbon and you come down to 4 and 1 you branch, so you will have H3, 2-methyl butane, 2-methyl butane. This is branched chain. You can have one more structure. From 4 you can come down to 3 carbon and 1 branch up and 1 down. CH3, CH3, CH3 and CH3. This is 2,2-dimethyl propane. Okay. This is also branched isomer. So what is the formula? Carbon 5, 3 to 5, 3 to 5, 10 and H12. Here also 3, 3, 6, 3, 9 and 3, 12. 3, 3, 6, 3, 9 and 3, 12. So molecular formula is same. Structure formula are different. And so these three are chain isomers. Okay, now we come to the position isomer. Positional isomerism, in that two or more than two chemical compounds will have same molecular formula, but they will differ in their properties due to the difference in the position of a multiple bond or a functional group or a side chain or a substituent. So we'll see faster the position wise. 1, 2, 3, 4. So we have CH2, H, H2, H3. This is your butene, one butene or just butene. And then other you can have a double bond here. And this is 2 butene. So position of double bond is at 1. And here position of the double bond is at 2. The position of the multiple bond is different. So these two are positional isomers. Now the functional group position different. 1, 2, 3 and 4 and H2OH. Even you can take 3 carbon also, in this case no problem. H3, H2. This is propanol. OH is at carbon 1. Then you have CH3, or make 1, 2, 3 carbon OH here. H3, H3. So here we have OH group is at 2. All is at 2. So this is position of OH, that is functional group is different. So these two are functional isomerism. Another important thing you remember, student, this group CH2OH group, this is called primary alcohol. I have taught to you what is primary carbon mean. Primary carbon is a terminal carbon, and so OH group is at primary carbon, so it is primary alcohol. And CHOH, that is this carbon, is secondary carbon. And so here it is 2, that's why not secondary. Secondary carbon is that which is surrounded by 2 carbons. So OH group is at secondary carbon, so this is secondary alcohol. So in other words, you can say if the molecular formula is same, molecular formula will be what? 3 carbon, hydrogen is 3, 4, 5, 6, 7 and 1, 8 and 1 oxygen. Here also carbon 1, 2, 3, hydrogen 3, 4, 5 and 3, 8 and 1 oxygen. So formula is the same molecular formula, but position of OH group is different. So one is primary alcohol, the other is secondary alcohol. So primary and secondary alcohol with same molecular formula are positional isomers. Now third kind, the side chain. So if you have 1, 2, 3, 4 and 5. So you have one here, H3, H3, H2, H2, H3. So here you have a carbon number 2 your methyl group. Okay. Then another example, if I rub this to make another this 1, 2, 3, 4, 5, and I put here the branch H3, H2, H2, H3. 1, 2, 3, 4, and 5. So here branch is at 2, here branch is at 3. So these two are your positional isomer. So side chains are different. Now we'll see for the substituent. So for substituent, you see, if you have 1, 2, 3, one chloro group here in H2 and H3, and you have 1, 2, 3, and one chloro group here, H3, H3. So here one chloro, and here we have got 2 chloro. So position of substituent is different. So they are positional isomers. Now the third kind is functional isomerism. When molecular formula is same but functional groups are different in the isomers, then for this you will have to learn a list. So I write down for that name of the functional group, or here I write functional group and functional isomer. Functional group and functional isomers. So first one is alcohol. Alcohol have the formula OH. They are having isomeric form, functional group as ether, this way. So I show also side by side the examples. If you have 1, 2, O, or take this way, CH3, CH2, OH, ethanol, C2, H6, O. And this can also be written like this. See, so this is alcohol, this is ether. This group and this group, ether. So molecular formula is same, 2 carbons, 6 hydrogen, 1 oxygen. But the functional groups are different, and therefore these two are functional isomers. So first example is your alcohol. Okay, the second example is aldehyde. Aldehyde, that is your CHO. Different ways are there, all you know. And they are with the ketone. So 1, 2, CHO, CH2, CH3. This is propanol or propanaldehyde. Propanol, and here 1, 2, 3. And here I write O, or this actually you can write this way also. So here I write this way, this, and this you can also write like this. Okay. So H3, H3. So carbon is 3, hydrogen is 6, and 1 oxygen. 3 carbon, 6 hydrogen, 1 oxygen here also. So this is aldehyde group, this is ketonic, and the two are functional isomer. The third example of functional group is your carboxylic acid. carboxylic acid. The formula is COOH and they are with ester. Ester is COOR. R means alkyl group, or you can put a dash here. R is actually there, I hope you know, is alkyl group. So if I take 1, 2 COOH, this is propanoic acid, and if I have to make its functional isomer, then I will write COO and 1 carbon here. So R is for this, so this is CH3. So what do we have? This CH2 I have taken that side, so CH3. So this is ester group, this is carboxylic group. Hydrogens are 3 to 5, 6, here also 6. Oxygen 2 here, carbon is the same. So these two are functional isomer. Then number 4. Cyanide or nitrile. Nitrile with nitrile is your C triple bond N with isonitrile, that is NC. So 1, 2 triple bond N is 3, then C N C is 3. So here we have got this and this, same atoms, same type of element, same atoms, so they are functional isomer. Number 5. Number 5 is one triple bond. Which triple bond? Carbon-carbon triple bond with 2 double bonds. Carbon-carbon double bond. So 1, 2, 3, 4, 1 triple bond and 1, 2, 3, 4, 2 double bond. So carbon atoms are 4, 3, 4, 5, 6, and here 2, 2, 4 and 2, 6. So molecular formula is same, but position of the type of the multiple bond is different. One triple bond with 2 double bonds. So they are functional isomers. Now 4th kind is a metamerism. Metamerism. Metamerism is a special kind of functional isomerism in which only 2 kinds, this is special functional isomerism. In this case, a functional group only that is considered which cannot be at the terminal, always in the middle. Like only 2 examples in your course, that is a ketonic group, not aldehyde, only ketonic group, and ethereal group. Ethereal. So ketone and ether you can say, ketone and ether. So I give you the example of metamerism. In this case, what is happening, I just show you. Take first example of ether. This is diethyl ether or ethoxyethane, IUPAC name, and how these two are variable. See the alkyl group on either side of oxygen. I told these two groups, so either side of this. Here ethyl, here also ethyl. In this case, this side methyl, but this side you have propyl. So when in a functional group, on either side don't have same alkyl group, in one this and in other it will be same alkyl group on either side of the functional group. Then such isomers are called metamers and isomerism is called metamerism. So these two are metamers. One ketonic example also you can see. This is pentanone 3 and here you can have in this you have one alkyl group here, one alkyl group here, ethyl and ethyl both are same. In the one side methyl, other side propyl. So alkyl, they differ in the type of alkyl group on either side of the functional group. So these two are metamers. Fifth kind is tautomerism and that I will teach you in the next class. So till then, bye.